Hello. In this video, I will do a GED PEMDAS order of operation videos. So we're going to go over PEMDAS order of operation, and they're not, there's only like a few problems I want to go over because it's pretty simple, it's pretty straightforward. Um, we're doing GED PEMDAS order of operation. So you could think of order of operation as something, what do I do first? That's how I see it. But before we go any further, I gotta write down some pandas rules. Okay, so pandas. So you've probably heard of it. P-E-M-T-A-S, right? P stands for parentheses, exponents, M multiplication, division, addition, or subtraction. So uh, parentheses, E stands for exponents, M stands for multiplication, D stands for division, A stands for addition, and stands for subtraction. Okay. So so what we want to do is here's some rules, some keynotes. To prevent mistakes, always write down what you haven't done. So when you're doing this, do not do it all at once because that's how you make mistakes. Do what you have to do first. Like if you have a parentheses, do that first, or if you have an exponent, do that first. Then bring down what you haven't done. So let me write that down. So to prevent, always write down what you have done. So bring down what you haven't done. That's another keynote is if you have both multiplication and division, always start from left to right. Same rule applies if you have an addition and subtraction. So, right, see here, if you have a multiplication and division at the same time, just go from left to right. The same thing with addition and subtraction. If you have them both, just go from left to right. Okay. So one more last thing about pandas. If you have more than one parentheses, always start in the inner parentheses and move your way out. Um, if you have one order of operation inside the parentheses, always use pandas again. So yes, sometimes you'll have problems with two parentheses or more than one parentheses. So what you want to do is start with the inner and make your way out. And if you have more than one order of operation inside the parentheses, just start with pandas all over again. I know that sounds confusing, but I'll explain. Okay, so yeah, um, yeah, just three rules. So let me go over the rules. So pandas order of operation, P stands for parentheses, P stands for exponents, N stands for multiplication, D stands for division, A stands for addition, S stands for subtraction. Um, yeah, to prevent mistakes, always write down what you haven't done. So don't do it all at once. Just write it up. Write the things you haven't done. If you have both a multiplication and division, always start from left to right. Same rules applies if you have addition and subtraction. Just go from left to right. If you have more than one parentheses, always start in the inner parentheses and then move your way out. And if you have inside the parentheses, if you have more than one order of operation, redo pendas all over. Like inside the parentheses, start with pendas to figure out which order of operations to do first. Okay, go ahead and copy this down. I'm gonna pause. I'm gonna clear, so go ahead and pause the video if you need to. And we are going to do three examples. That's it. So I'm gonna clear. So let's start with question one. Which of the following is we gotta simplify this. So I believe the asterisk, do you see the asterisk? It means multiplication. So let's see here. We have a parentheses, right? We only have one parentheses. So we're gonna do with pendas. Still, we're gonna do pendas. But inside this parentheses, as you can see, we have more than one order of operation. We have an addition, we have a multiplication, we have a minus, and then we have an addition, right? So if your inner parentheses has more than one order of operation, start with pandas all over again. So inside the parentheses, do we have an exponent? No, we don't. So we can forget about that. Do we have inside the parentheses, do we have a multiplication? Yes. Do you see the asterisk? It means multiplication. So I believe we have two. So we have a multiplication here. So what's 2 times 8.05? So you can use a calculator on the exam, so go ahead and use it. So 2 times 8.05, that's 16.1. So you're going to put 16.1, right? And then bring down what you haven't done. So as you can see, you have an addition, so bring that down. And then our other multiplication is 4.5 times 6.05. That asterisk means multiplication. So that's going to be 27. I'm going to write it out, 27.5275. And then you have a minus, bring that down, and then close it with parentheses, and then bring down what you haven't done. So you still have this extra minus here, and then you have this 15.555, 50.55. Okay, okay, we are still doing the parentheses. We still have some stuff to do inside this inner parentheses. So what do we do next? You said we had a multiplication. We did the multiplication. Do we have a division? No. Do we have addition and subtraction? Yes, yes, we have both, right? Same time. So what you want to do is just go from left to right. So what's 6.5 time plus 16.1? 6.55 time plus 16.1, 22.65 minus 27.5275. Bring down what I haven't done, so you have a minus here, and then you have the 15.55. Then what I'm going to do is simplify this. Um, we have a minus, so just one last order of operations. So 22.65 minus 27.5275. So I get negative 4.8775, and then bring down minus, and then you have 15.55. Okay, so we did the parentheses. Now what's next? So what you're going to do is start with PEMDAS all over again because we're done with the parentheses. So start with PEMDAS all over again. So forget about the p because we finished that. Do we have an exponent? No. Do we have a multiplication? Yes, kind of. Do you see this minus? This is like an invisible -1. So we do have a multiplication. What's -1 times negative 4.875? Positive 4.775. And then bring down this 15.55. Okay, so we did that. We did the multiplication. We don't have a division. The last one was an addition. So just add 15.55. And I get 20.4275. And what is that answer? I think it's B. It's not A. It's not C. It's definitely not B. It's 20.4275. Exactly, no rounding. Okay, so that is an example of an order of operation. Okay, so just stay neat, do your order, and you'll get it right. I mean, you won't get it wrong. Okay, let's move on to question 2. Okay, question 2 says Lisa worked 4 shifts at Sunshine Bookstore last week. She had 2 shifts, both were 5 hours long. She had another shift that was 3.5 hours long. During her last shift, she worked 3/4 hours. How many hours did she work together? So imagine Elisa, she had 4 shifts. One, two, three, four, eight. So the first shift, she had 2 shifts, both were 5 hours long. So you could put a 5 + 5, or you could also say 2 times 5, right? She had 2 shifts that were 5 hours long. She had another shift. Wait, she had 2 shifts. Both were 5 hours long. She had another shift that was 3.5 hours, so you can add 3.5. During the last shift, she worked 3/4 hours. 3/4. Okay. So just clean it up. So order of operation, it's really just an addition and subtraction. So you just go from left to right. Right, 5 + 5 is 10, plus 3.5, plus 3, 4. Um, you can convert 3/4 as a decimal because choices are all multiplication. your exam is all multiple choice. So if you want, you can put convert 3/4 as a decimal. So if you then calculate, you get 0.75. Okay, add them up. 10, 3.5, 0.5, what do you get? 14 points. So which one is these is equivalent to 14.25? Not A, not B. What about 14.1/4? Well, what is 1/4 as a decimal? Is 0.25. That's the one, right? 14 and 1/4 is the same thing as 14.25. Okay, not too bad. This one's not too bad. Oh, here's a good one. So this one is involving, let me read the question. Given A equals 1/2 and B equals -3/5, evaluate A minus B all over A squared minus B squared. So we have what's called a complex fraction. Um, so if you need a refresher on complex fraction, there is a video on complex fraction, but I'll just go over step by step. So let's, you see the numerator, we have A minus B. So we're just going to replace our A and our B values. So our A is 1/2 minus B. So be careful, it's a minus, and then you have a -3/5. Okay, I'll clean up that later on, but let's do the bottom. The bottom is A squared minus B squared, so my A is 1/2 squared minus my B, which is -3/5 squared. Okay, so this whole thing is your numerator, and this whole thing is your denominator. So on the top, what is 1/2 to minus and -3/5? Well, we know that two minuses becomes a positive, so that's going to be 1/2 plus 3/5. And then on the bottom, what's 1/2 square minus 3/5 square? Well, we know that 1/2 square is 1/4 minus 3/5 square. What is 3/5 square? That's the same thing as 3/5 times 3/5. Well, that is 9/25. Okay, so we definitely have a complex fraction. So this is our numerator, and this is my denominator. Okay, so what we're going to do next is simplify it. So let's put everything in a fraction form because that all our choices are in fraction. So let's simplify 1/2 plus 3/5. So what is 1/2 plus 3/5? So if you recall, when you're adding or subtracting fractions, you do need what's called an LCD, lowest common denominator. So look at the bottom, we have a 2 and a 5. What do you think my LCD is? Yes, it is 10. The reason why, so if you forgot how to do LCD, lowest common denominator, there is a video on the supplementary video on LCD. It explains all details how to find the LCD. But um, in short, to find the LCD, what you do is look at the numbers on the bottom, factor it. If it can't be factored, 2 and 5 is prime, right? So my bases are 2 and 5, and they can't be broken down. Usually, the numbers on the bottom is not prime, and you got to make a factor tree. But because these numbers are prime and they're different bases, right? This is a base of 2, this is a base of 5. You just put it all together. So 2 times 5 is 10. So that's how I got an LCD of 10. So if that's true, that means over here I gotta multiply 2 by 5 to get 10, top and bottom. And then same thing here, I'm gonna multiply 5 by top and bottom by 2. So on the bottom you get 10. On the top, 5 times 1 is 5, plus 3 times 2 is 6. And then 6 plus 5 is 7, 8, 9, 10, 11. Tenths. Now do the same thing on the bottom. So it's all over 1/4 minus 925. What is my else? This time it's not prime. 4 could be broken down as 2 times 2 or 2 squared, right? 2 is prime, 2 is prime. So 2 times 2 is the same thing as 2 squared. The same thing with 25. It can be broken down as 5 and 5 or 5 squared. So what is my LCD? So the good news is they're different bases. This is the base of 2. This is the base of 5. So if they're different bases, just put it all together. So it's 2 square times 5 square, which is what? Well, 2 square is 4, 5 square is 25, and then 4 times 25 is 100. Okay, so my LCD is 100. So over here, we're going to multiply 20. What do we have to multiply to 25 to get 100? 4. So multiply times by bond of 4. And then over here, what do you have to multiply 4 to get 100? 25. Okay, so on the bottom, it's 100, your LCD, and then it's 25. And then 9 times 4 is 36. So this is a minus. So what is 25 minus 36? It is a negative 11. Okay, so this is what we got. On the top, it's simplified as 11 tenths. All over, see how this, do you see the cylinder sign? Negative 11, negative 11 over 100. So we had definitely have a complex fraction. If this is your numerator, this is my denominator. So what we could do, if you have it something like this, you can rewrite this. So the numerator is 11 tenths divided by your denominator, which is negative 11 over 100. So you can rewrite this complex fraction like this. Okay. Then what I'm going to do is, you see this divide sign? I could change that to a multiplication. And then I would have to flip this. So it would be 100 over 11. And then this is 11 over 10. Okay, go ahead and simplify. So now when you're multiplying fractions, you multiply across, not crisscross. So 11 times negative 100 is negative 1100. And then 10 times 11 is 110. And what happens is one of these zeros cancels. So now you're left with negative 110 over 11. And then I do believe this comes out nicely. Negative 110, negative 110 divided by 11 is exactly negative 10. Okay. So this is like a brief example, a brief introduction of complex fraction. So if you need a refresher on complex fraction or on lowest common denominator, what you want to do is on this course, scroll down to the supplementary videos and look for complex fraction and LCD. It explains more in depth of how to simplify complex fraction and LCD. But I did explain it. So, but if you just need more help. Okay, so it's negative 10. So yeah, this was only 3 questions, but these were good questions. So I am going to stop here.